Picture this, a planet. Not just any planet, but one made entirely of pure, sparkling diamond, a celestial marvel that dazzles with the brilliance of a million gemstones, casting light in a breathtaking display of cosmic splendor. It sounds like the stuff of science fiction, a fantastical dream confined to the realms of imagination. Yet, the universe is brimming with wonders that often outshine our wildest fantasies. But what if we could bring this dream to life? What if our leaps in technology and science could make this vision a reality? Imagine having the power to reach into the cosmos and craft a celestial diamond. Think of the possibilities, the new frontiers we could explore, and the profound knowledge we could uncover. What once seemed like pure fantasy is now a tantalizing possibility, a testament to our ever-expanding understanding of the universe. Our relentless quest for knowledge has brought us to the brink of turning the impossible into reality. The mission to build a diamond planet is a journey into the core of astrophysics, engineering, and ethics. It demands that we push the boundaries of our knowledge and innovate in ways we never imagined. It challenges our perceptions of what's possible and forces us to confront the implications of such bold endeavors. What would it mean for humanity to create a new world, a diamond planet? This journey promises to unveil not only the secrets of the cosmos, but also the potential of humanity itself. As we reach for the stars, we discover more about our own capabilities, our resilience, and our insatiable curiosity. The dream of a diamond planet is not just about the destination, but about the journey and the discoveries we make along the way. And a diamond planet, as the name suggests, is a celestial body composed primarily of pure crystallized carbon. Imagine a world where the very ground beneath your feet sparkles with the brilliance of countless diamonds, a place where the landscape is a continuous expanse of glittering facets. It's like stepping into a cosmic jewelry box. Unlike our Earth, with its diverse geology and abundance of life, a diamond planet would be a stark, glittering world. The surface would be barren, devoid of the lush greenery and vibrant ecosystems we are accustomed to. Instead, it would be a mesmerizing yet desolate expanse of shimmering diamond, a true testament to the wonders of the universe. Its surface, a dazzling expanse of faceted brilliance, would reflect starlight with unparalleled intensity. The light from nearby stars would dance across the planet's surface, creating a spectacle of light and color that would be both breathtaking and otherworldly. Imagine the night sky on such a planet. These cosmic diamonds form under extreme conditions far different from those found on Earth. The environment in which these planets are born is one of intense pressure and heat, conditions that are rarely found outside the hearts of stars. It's a process that defies our everyday experiences. They are born from the hearts of dead stars, white dwarfs, which are essentially stellar remnants composed mostly of carbon and oxygen. When a star like our Sun exhausts its nuclear fuel, it sheds its outer layers and leaves behind a dense core. This core, a white dwarf, is where the magic happens. It's like a cosmic alchemy. Under the immense pressure and heat deep within these collapsed stars, carbon atoms bond together in a tetrahedral lattice, the signature structure of diamond. This process, which takes place over millions of years, results in the formation of a diamond planet. A slow yet magnificent transformation. The discovery of 55 Cancri E, a planet twice the size of Earth and with 8 times its mass, sent ripples of excitement through the scientific community. This exoplanet, with its unique composition and characteristics, provided a tantalizing glimpse into the possibilities of diamond planets. It was a groundbreaking moment in astronomy. This exoplanet, orbiting a sun-like star 40 light-years away, is believed to be a carbon-rich world. Its proximity to its star means it experiences extreme temperatures which could contribute to the formation of diamond on its surface in a fiery forge for cosmic gems. While not entirely composed of diamond, 55 Cancri E hinted at the existence of such exotic planets and fueled our imagination about the possibility of creating one ourselves. The idea of a diamond planet challenges our understanding of planetary formation and composition and opens up new avenues for exploration and discovery in the vast expanse of space. It's a concept that stretches the limits of our imagination. Imagine the technological advancements and scientific breakthroughs that could arise from studying such a unique and extraordinary world. the allure of a diamond planet continues to captivate our minds and inspire our quest for knowledge about the universe. It's a beacon for future exploration. As we develop more advanced telescopes and space observatories, our ability to detect and study these celestial marvels will only improve. The mysteries of diamond planets beckon us to explore further, to push the boundaries of our understanding and to uncover the secrets hidden within these glittering worlds. The journey has just begun. Building a diamond planet requires an astronomical amount of carbon, the fundamental building block of diamond. But where would we find such a vast supply? Let's explore the cosmic sources of carbon. The answer lies in the cosmos itself. Stars, the cosmic furnaces that light up our universe, are natural carbon factories. Through a process called stellar nucleosynthesis, stars fuse lighter elements like hydrogen and helium into heavier ones, including carbon. This process is the heart of star chemistry. As stars age and approach the end of their lives, they undergo dramatic transformations. Red giants, for instance, shed their outer layers, while supernovae explode, dispersing carbon and other elements into the interstellar medium. These cosmic events enrich the universe with the building blocks of life. Another potential source of carbon lies in carbon-rich asteroids. These celestial bodies, remnants from the early solar system, contain significant amounts of carbon in various forms, such as graphite and organic compounds. They are like time capsules holding the secrets of our solar system's formation. Capturing and mining these asteroids could provide a substantial supply of raw materials for our Diamond Planet project, making them invaluable for our ambitious endeavor. Imagine robotic miners extracting precious carbon from these ancient rocks, fueling our quest to create a sparkling new world. Creating a diamond planet isn't as simple as gathering a huge amount of carbon. It involves a complex and intricate process that goes beyond just the accumulation of carbon atoms. The journey from carbon to diamond is a mesmerizing transformation that requires conditions that are almost unimaginable. Transforming this carbon into dazzling diamond requires recreating the extreme conditions found deep within white dwarf stars. These stars, remnants of once massive suns, have cores where temperatures soar and pressures are immense. It's in these stellar furnaces that carbon atoms are forced into the diamond structure. This means subjecting the carbon to immense pressure and temperatures that would make even the Earth's core seem like a cool breeze. The core of our planet, with its intense heat and crushing pressure, is nothing compared to the conditions needed to forge diamonds on a planetary scale. Imagine a cosmic pressure cooker, a colossal, technologically advanced structure capable of generating pressures millions of times that of Earth's atmosphere. This hypothetical machine would need to withstand and generate forces that are beyond anything we currently have the capability to produce. Inside this pressure cooker, carbon, heated to temperatures exceeding thousands of degrees Celsius, would begin to transform. The heat alone isn't enough. It's the combination of extreme heat and pressure that initiates the metamorphosis of carbon into diamond. The intense pressure would force the carbon atoms to bond together in a tight tetrahedral lattice, the defining characteristic of diamond. This lattice structure is what gives diamonds their incredible hardness and unique properties. This process, known as high-pressure/high temperature HPHT synthesis, is already used on Earth to create synthetic diamonds. In laboratories, scientists replicate these extreme conditions on a much smaller scale to produce diamonds for industrial and gem quality purposes. However, replicating this process on a planetary scale would be a monumental engineering challenge, requiring technologies far beyond our current capabilities. The scale of such an endeavor would be unprecedented, involving not just advanced machinery, but also new materials and energy sources. Scientists and engineers would need to collaborate on a level never seen before, combining knowledge from astrophysics, materials science, and engineering. The creation of a diamond planet would be a testament to human ingenuity and the relentless pursuit of knowledge. The end result, a planet made entirely of diamond, would be a marvel of the universe. It would shine brilliantly, reflecting light in a way that no other planet could. This celestial gem would be a beacon of what humanity can achieve when we push the boundaries of science and technology. As we look to the stars, the dream of forging stellar diamonds reminds us of the endless possibilities that lie ahead. The universe is full of wonders waiting to be discovered, and with each step forward, we get closer to unlocking its deepest secrets.